Hi, hello everyone. In this video, we discuss about implicit differentiation. So we discuss up to second derivative using implicit concept. Right, before we further go to how to differentiate using implicit, so let's take a look what's the difference between implicit and explicit. So for this one is explicit. So in explicit, left hand side only single term, okay, single term, only y. However, for implicit, so as you can see on the left side, we combine together x and y terms. So same also here on the left hand side, we have both x and y. So this is the cases that have it implicit. So let's take a look at example 19 here. So differentiate each term with respect to x. So the first one, y squared. So differentiate y squared, we treat as a x, so we differentiate power. So we bring 2 to the front and then power will reduce by 1. So we got 2y. And we have to multiply with dy dx because the term is y. So remember this. If you differentiate y, so remember we differentiate like x, and we need to multiply with dy dx. Okay. So let's take the next question. So here we have two terms. So we will use product rule u and v. So as you can see here, so we have u v prime plus v u prime. So u is x cubed and then v prime. So differentiate y 1 times dy dx. So that's why it become dy dx here. And then vy and then u prime differentiate x cubed will get 3x squared. So we simplify. So we arrange, we put y at the back. So x cubed divided dx plus 3x squared y. Okay, now for question C. Differentiate x divided dx. So don't confuse with the dx here. So just treat this one as a u and this one as a v. So we still have to use product rule. So u v prime plus v u prime. So differentiate dy dx. We'll show later how we differentiate dy dx. And then v u prime, so differentiate u, we know x is 1. So as you can see here, when we differentiate dy dx, it will become the second derivative. That is d2y. And then here, we know it is 1. So 1 doesn't make an impact. So the answer is just like that. That is x and then times second derivative of y in with respect to x plus dy dx. Okay, now for question D, we have ln xy. So remember, this is ln. Okay, and then as you can see here, we are using rules of log. So we know rules of log. So inside function ln, if it is multiplied, we can split and then we become ln x plus ln y. And then we can differentiate separately between ln x and ln y. So for ln x, it will be 1 over x. And for ln y, also it will be 1 over y. But since it is y, you have to multiply with dy dx. So don't forget dy dx here. And then there's nothing much to simplify, and that will be the final answer for question D. Okay? Right, so now we move to the question E. So for question E, we have exponent ex plus y. So remember, differentiate exponent. First, we copy the exponent, and then we differentiate the power. So we copy the ex plus y, and then the power here. So differentiate x is 1, and then differentiate y is dy dx. So that will be the answer, nothing to simplify anymore. Then lastly, differentiate sine x minus y. So remember, for sine also, first we differentiate trigo. Remember I mentioned about 3 layer before. So here we have only 2 layer. So first we differentiate trigo, and then secondly we differentiate inside function trigo. That is x minus y. So differentiate trigo only, so sine will become cos x minus y. And then we differentiate x minus y. So differentiate x will be 1, and then differentiate y will be dy dx. So the answer is just like that. So that will be the answer for question F. Right, so now we'll look at example 20. Find dy dx if ln xy equals to ey. So this time we have an equation. So we will differentiate on both sides of the equation. So we have to put this notation to mention that we need to differentiate on both sides of the equation. So ddx in bracket ln xy, and then on the right hand side ddx ey. Right? And then don't forget here using rules of log. So we can split the ln x plus ln y. And then here we differentiate. So differentiate ln x is 1 over x. Remember the previous example, we have the same question, right? And then ln y will be 1 over y divided x. And then on the right side, ey. So remember it is exponent. Remember exponent, first copy the exponent, and then differentiate y. So differentiate y, remember whenever you differentiate y, you have to put dy dx. So differentiate y is 1, so only dy dx. Okay? Right, the question asks about dy dx. Means that it is dy dx equals to in terms of x. So in this case, we have to rearrange the equation. So let's take a look on the next slide how we rearrange. Right. Now, as you can see, we already bring 1 over y. So we minus 1 over y divided dx. So we're leaving only 1 over x on the left hand side. Okay, and then you notice that here over y, and this one ey no over y. So later on we have to divide. So to make it easier for us to divide later on, so you have to equate the denominator here. So this is what happened on the next step. That is so we equate denominator, so we multiply with y. So y ey minus 1 over y, right? So and then later we can bring this to the right hand side, so it become like this. So we can divide. So when we divide, so we just swap places between numerator and denominator when we bring to the right hand side. So now it will be y above, and then denominator, so x here will multiply with y ey minus 1, right? So this will be the answer for this equation, that is to find dy dx. Remember, as I mentioned before, it's not only we differentiate with respect to x, but later on you have to rearrange to make it dy dx as a subject. Okay? Right, so now we move to the example 21. So this time we are dealing with equation that having trigo function. So same as example 20, it is also an equation, find dy dx. So bear in mind later after we differentiate, you have to rearrange to put a dy dx as subject. Okay. So first we differentiate. So we know differentiate y will get dy dx, right? And then differentiate cos will get negative sine. Okay. But remember, since we differentiate y, so remember to put dy dx after that. And then on the right hand side, differentiate x will get 1. And then differentiate cos is also negative sign, same as on the left hand side. But this time, since it is x, so no need to multiply with dy dx lah. Okay. Okay. So now as you can see, we have two terms that have dy dx, and coincidentally, both of them already on the left hand side. So we just factorize straight away. So it is 1 minus sine y. And then don't forget lastly, we need to bring this 1 minus sine y to the right hand side. So we will divide. So therefore the final answer dy dx is 1 minus sine x over 1 minus sine y. Okay, so that's the answer for example 21. And then, we also have a question B over here. So look at question B. So this time given sine x minus y equals to y cos x. So also find dy dx, right? And then before we proceed to the solution, just to like to remind you that if you notice here on the right hand side, we have two terms here. So don't forget, we have to use product rule in order to differentiate on the right hand side. Okay, so don't forget the u prime here, since it is y, so it will be dy dx, and then v prime would be what? Remember the previous example, it will be negative sine x. Okay, so let's see the solution. So as you can see, so we already applied the product rule over here. So u v prime, so the negative they already put straight away on at the front, right? And then this one is u v prime. So this is u, sorry, this is v, and this one is u prime. Okay, and then on the left hand side, also like the previous example, differentiate sine is cos. Okay, and then don't forget we just copy, and then later we differentiate inside here. So differentiate x will be 1, and then differentiate y will be dy dx. Okay, so that's the differentiate on the left hand side, right? So let's see. If you notice that we have two terms that having dy dx, one on the left hand side and one on the right hand side. So let's see where they want to put here. It seems that they expand first. Okay, expand first before we can bring all dy dx on the one side. So expand first, right? So after expand, we got this. We got two terms on the left hand side and two terms on the right hand side. And then after that, we bring all terms that having dy dx on the left hand side. So means that this one we bring to the left, and this one cos we bring to the right. Okay, so that will happen on the next step, as you can see. And then after that, of course, as you know, we will factorize dy dx. So factorize dy dx, and maybe some of you wonder why we factorize also the negative. Okay, it is because that since we have both negative sign here, so maybe they think that it is easier if we factorize negative also. Okay, so they factorize negative together with dy dx on the outside. So inside here it will be both positive lah. That is cos x minus y plus cos x, right? And then after that, you know that we will bring this on the right hand side, and then as you can see, okay, they already at the denominator over here. And then you may notice that the negative already disappear. You know why? Because here on the right hand side, they all also have both negative terms. So if we factor out the negative, so it will be positive. So this negative, we can cancel out with the negative on the left hand side. So that's why at the final answer, both term has a positive sign, no negative at all. Okay. So that's the answer for example 21. Right, so now we move to example 22. Right, so determine the value of dx for 3y power of 3 minus 2 over x squared equals to xy squared at the point 2, 1. Right, so the difference in this question compared to the other question is we have a certain point, given certain point. So bear in mind, if you come across with this kind of question, later on you have to sub the value of x and y from the coordinate given. Okay, so that one will be later, but first we try to differentiate first, right? So let's see here, we have 3y power of 3, so we just differentiate power first. So 3 will bring to the front will be 9, and the degree will reduce by 1, so it will be y squared. And then don't forget, since it is y, you have to multiply with dy dx, right? And then here, negative 2 over x squared. So if you're not familiar how on earth we got 4 over x cubed, you just can rewrite like this first, negative 2, x power of negative 2, and then we know later you have to multiply with negative 2 outside, and then x, and the power will further reduce by 1. Okay, so at the end, negative will be positive 4, and then we bring negative 3 back to the denominator, it will be over x cubed, right? Okay, so that's on the left hand side. So look at the right hand side. So as you notice here, we have two terms, so don't forget you have to apply the product rule. So apply the product rule, uv prime plus vu prime. So this one is u, this one is v. So differentiate y squared, it will be 2y, and then since it is y, you have to multiply with dy dx. And then plus vu prime. So v is y squared, and then u prime, differentiate x is 1. So that will be the product rule on the right hand side. Right. So after that, as you know, we will rearrange and then put all terms that having dy dx on one side. So let's see that one on the next slide. Oh, it seems that we don't have to rearrange first, but they straight away substitute the value because this time they given the value. Okay, never mind, since the value already given, so we just sub the values straight away. So sub the value, y equals to 1, and then x equals to 2. Okay, so this one will be the value of x lah. 2 will be value of x, this one y, this one x, y, and also, okay. So, and then, well, it will be much easier, right? After we sub the values. So 9, and then this one is 4. So bring here 9 minus 4 is 5 dy dx, and then here 1 minus 1 over 2. Of course, it is 1 over 2. And then lastly, bring 5 to the right hand side, so we divide by 5. So that's why the answer is 1 over 10. Okay. So that's for example 22. Remember to substitute the value of x and y. Right. So next we move to the second order derivative. As I mentioned in the beginning, for implicit differentiation, we also discussed a couple of questions regarding to find the second order derivative. Right. So look at here example 23. We have two questions, A and B. So for question A, given equation xy plus y squared equals to 3. So first we differentiate for the first time. So remember xy means that we have two terms. So don't forget to apply the product rule. So u v prime plus v u prime. So differentiate y divided dx, don't forget. So that's why we got x divided dx plus y times 1. And then for y squared, so differentiate power, so it will be 2y. And don't forget, since it is y, you have to multiply with dy dx. Okay? And then on the right hand side, we have constant. So don't forget, when we differentiate constant, it will be 0, right? Okay, next we rearrange. So the terms that doesn't have dy dx, we bring to the right hand side, and then the having dy dx we will factorize. So that's what happened. So we factorize dy dx will be x plus 2y, and then we bring y, it will be negative y on the right hand side, and then lastly put dy dx as subjects will be negative y over x plus 2y. And then don't forget, later we have to differentiate again to find the second order derivative. So look at the next slide. So we apply the quotient rule since we have a quotient. So x plus 2y, so it will be v. This one v, this is u prime. So remember the above there is negative y, so that's why it will be negative dy dx. And then here minus u v prime. Okay, so differentiate x1, differentiate 2y, it will be 2 dy dx. And then divide by v squared. So v x plus 2y and then squared. Okay, and then don't forget the second derivative also in terms of x and y. So later this dy dx you have to replace. So remember dy dx equals to negative y over x plus 2y. So we substitute that. Oh, already show in the solution there. So substitute, it will be like that, and then we just simplify. Just simplify, and then don't forget also when we simplify over here, it will be positive y. Okay, then expand the positive y to the inside. And then after we simplify and cancel out the similar terms, and then don't forget on both terms we have x over x plus 2y, so we can bring down because it is the common term. So that's why the below here it will be power of 3. Remember, for differentiation, it's not only apply the formula, the rules, but the final answer you also have to simplify and give your answer in simplest form. Okay, so next we further simplify. How on earth it will be 3? So check the original questions. So that's why we can substitute with 3. So if you notice, if we factorize 2, it will be xy plus y squared. So x squared plus y actually the original question, right? Equals to 3. So that's why we replace with 3. So this would be our simplest form and not this one, because we can simplify and substitute this one with 3. That's why I told you, you have to check, be very careful and make sure your answer in the simplest as possible. So 2 times 3, the final answer will be 6 on the numerator, and then denominator x plus 2y power of 3. Okay, So now we move to the question B. So question B, x squared plus y squared equals to 4. I think question B would be much easier compared to the question A because we don't have a product rule over here. So we just say straight away differentiate x squared to x, differentiate y squared to y, and then don't forget we have to multiply with dy dx because it is y. So don't forget dy dx because it is y. And then we rearrange. So we bring 2x to the right side. So it will be negative 2x over 2y. So we can simplify 2. So that's why the answer is negative x over y. And then later we have to differentiate to find the second derivative. So again we apply the quotient rule. So remember quotient rule, vu prime minus uv prime over v squared. So v is y, u prime, so differentiate x, negative x will be negative 1. And then uv prime, so differentiate y divided x. Okay, so that's apply the formula. And then as the previous question, we also have to replace dy dx. So remember dy dx is negative x over y. So replace with that. So that's what happened on the next step. And then later we can factorize. So notice here we have over y. So in order to make it easier for us to factorize, so you have to equate denominator. So y above here maybe it will be squared. Okay, that's what I told you. So we can bring y up below here and will be y cubed, and then y, as I mentioned before, it will be y squared, and then negative plus x squared. And also here negative, so 3 times it will be negative lah. So it means that negative y squared, negative x squared. So they decide to factor out negative. Remember the previous example, when both terms have a negative sign, they factor out the negative. So factor out negative, so inside here positive y squared plus positive x squared over y cubed, right? So that's for example 23. And then remember, like a question A, y squared plus x squared. So check the original question here. It is actually equals to 4. So we can replace that with 4. So the most simplest possible answer that we can get is over here. That is negative 4 over y cubed. So that will be the answer for question B. Okay, now we move to the example 24. So here in example 24, we have a situation that having exponent and also trigo function, and they ask to show this equation that consisting of the second derivative, first derivative, and then the original function y equals to 0. So first, from the equation given, y equals to e negative x cos x. So they bring ex on the right hand side, so will be y times ex. I'm not sure why they choose this method, so never mind, we just see how they solve this one. So differentiate implicitly. Okay, they differentiate implicitly. So remember on the left hand side we have two terms, so remember to apply the product rule, u and v. So it would be uv prime plus vu prime, but I notice here they use vu prime first, plus uv prime, and not maybe they want to put dy dx on the left, but never mind, since it is plus, well, whether it's vu prime or uv prime, it doesn't matter, it's still the same answer. And then on the right hand side, so differentiate cos is negative sine, and then the factorize exponent, so factorize exponent, it will be dy dx plus y equals to negative sine x, right? So let's see what they do on the next step. Is it differentiate again? Yes, they differentiate again. So they factorize so that the inside factor it would be v lah. Okay. So again they use vu prime plus uv prime. So because differentiate exponent also got exponent, okay, it doesn't affect. So we got this, and also here for uv prime, and then on the right hand side, so negative sine x differentiate negative cos, and then they divide by exponent, so they will get an exponent negative x on the right hand side. Maybe in other situation, maybe we just factor out, because since all the terms on the left hand side have an exponent, so maybe it just factor out exponent, I think the most correct way. So they bring ex to the right hand side, so it will be e negative x, okay. I think that one will be more appropriate lah, compared to divide by ex, but it doesn't matter, it carry the same meaning. And then after that, as you can see here, we check with the original question. On the right hand side here, e negative x cos x is actually y, so we can replace with y. So on the right hand side it will be negative y, okay. So as you can see, they replace with negative y, so it will be negative y on the right hand side. And then on the left hand side, the simplify. So since here we have 2 dy dx, so we just sum, it will be 2 dy dx, and then the second derivative, and then here negative y, they bring to the left hand side, so negative, it will be positive y lah. So positive y plus y, it will be plus 2y. So at the end, we can show that the one that they need to show lah in the question. Okay, so that's all for the video. I hope you understand what we discussed in this video, and later don't forget to answer all the questions in the tutorial book to make sure you understand how to perform implicit differentiation. So after this video, we will move to the next subtopic, that is 9.5, regarding parametric differentiation. So just to remind you, before we go to the parametric differentiation, make sure you read again about chain rule. Okay, because we will use chain rule in order to solve parametric differentiation on the next video. Okay guys, I think that's all for now. I hope you enjoy it. Thank you.